The sun is releasing massive spurts of energy that are headed directly toward Earth. And if they hit us, it could change everything. Power grids could be wiped out. Our communications could cease to exist. Humanity might be put back into the Stone Age. All because of a solar storm. But what makes them so powerful? How is it possible for something like this to happen in 2024? And why are they so dangerous? This is What If, and here's what would happen if a solar storm hit Earth in 2024. So, how could something like this happen anyway? Well, it all starts with the cycle of our sun. Known as the solar cycle, this is an 11-year stretch in which the sun's solar activity increases and decreases. The cycle starts with just a few sunspots raging about and creating mass amounts of energy, and then 5 or 6 years later, it reaches its peak with anywhere from 100 to 200 sunspots. Then it ramps back down for the last 5 years, and we start another solar cycle. You know, these cosmic threats probably aren't the most likely thing that could destroy Earth. What's a lot more likely to hurt our planet is climate change. Hurricanes, forest fires, and rising sea levels are all becoming more frequent due to the Earth heating up. But luckily, the Environmental Protection Agency is working to help solve this. There are new rules in place that incentivize coal and natural gas power plants to cut or capture 90% of their climate pollution by 2032. This could reduce the carbon emissions from these plants by 75%, bringing them back down to levels we haven't seen in almost 2 decades. The EPA has also announced stricter rules that will force these companies to have safer disposal for toxic wastewater and coal ash, byproducts of making electricity in these plants. But that's not all. Companies are being incentivized to retire fossil fuels entirely, shifting to energy sources like wind and solar, both of which are cleaner and cheaper to produce energy from. If we want our planet to stick around, it's essential that our leaders prioritize making progress on carbon reduction. Currently, we're in our 25th cycle since we began tracking the sun in 1755. And unfortunately for us, scientists predict that the sunspots will peak in 2024. This means there's a higher chance that a solar storm will occur. Now, before we get to our solar storm, what are sunspots anyway? Well, they're cooler and darker areas of the sun that are created by a strong magnetic field. They're not directly responsible for creating solar flares, but it just so happens that flares are most common in these sunspots due to their high magnetic activity. The magnetic field lines can become twisted and tangled near certain parts of the sun, and they can suddenly snap and realign, which creates a massive burst of energy. This can result in a solar storm. So now that the sun has released this massive amount of energy, what will happen to you on Earth? Well, when a solar storm occurs, you won't notice it right away. That's because it takes a few minutes before it reaches Earth. Hurry up and get in your last couple of YouTube videos, because once this storm hits, everything changes. Now, the first thing you might notice is that more and more auroras will start popping up worldwide. This typically happens when charged particles from the solar storm interact with the Earth's atmosphere. Although these sights in the sky look beautiful, the good parts about a solar flare end there. Due to the effect on our geomagnetic field, most of our technology would stop working. Things like satellites, GPS, and radio transmissions would become incredibly spotty. Your cell phone likely wouldn't be able to pick up any signal, and communications worldwide would start to fade out or become less reliable. But that would only be if we were affected by a few solar flares. This is an entire solar storm we're talking about here. These are comprised of multiple attacks by the sun on the Earth. But before we get to that, people on Earth aren't the only ones affected by this. Astronauts up in space would also suffer the consequences. their situation could be a lot worse. The sun would be blasting them with intense solar radiation, and if they're not in a specially shielded area on the spaceship, a solar storm could prove deadly. They could get radiation sickness as well as develop cancer later on. The solar storm could also destroy their ability to communicate with their mission control and vice versa. This is just what would happen on the first day of the solar storm, but several days later, as you're still having trouble getting cell reception, another massive attack would come from the sun. A phenomenon known as a coronal mass ejection, or CME for short, would be coming right for Earth. A CME is a massive explosion of plasma and electromagnetic radiation from the sun. This mass ejection can cause violent geomagnetic storms that interfere with Earth's magnetic field. If this were to happen, Earth as we know it could change for good. Just look at what happened in 1859. A solar storm known as the Carrington event occurred. It disrupted and flat out destroyed telegraph communications. Luckily, in this case, Earth was able to recover relatively quickly from what today would be a cataclysmic event. Telegraph communications were a simple technology. Telegraph lines could be repaired quickly and things went back to normal. But what would happen today? Our lives are so much more reliant on technology, and we have so much more of it. This time, the tech interruptions wouldn't just stop with the odd glitch or spotty signal. Instead, a solar storm could be so bad that it would make all technology stop working. Yeah, the intense levels of electromagnetic radiation could wipe out entire power grids and communication systems. Even something as simple as buying groceries with your credit card would be impossible. We're talking about a full-on global blackout. If you were in an airplane, the cockpit could lose communication with air traffic control and not know where to go. Or, with the intense radiation levels hitting Earth, the plane could fall entirely. The same goes for subways and trains. They could come to a complete stop in their tracks. This would cause catastrophes all around the world. Planes falling from the sky, trains crashing. Now, not having power at your house would be the least of the world's worries, because entire cities, including all hospitals, would be without power. No power means it's harder or impossible to treat certain patients. The lack of power and technology malfunctions could cause millions of people to die. The solar flares and CMEs might last anywhere from a couple of hours to a few days, but that doesn't mean this event would be over just yet. Because of all the damage to our power grids, communications, and technology, Earth would take some time to recover. It might be weeks or months before we get back to normal. We'd have to rebuild parts of our power grids and communication systems. And depending on the parts needed, well, this might take another several weeks. And take into account the lack of communication that the world would suffer. I mean, talking to your neighbors is one thing, but how would you communicate with another city or country? Global supply chains would collapse. This would delay things even further. But once humanity got all these things sorted, we would rebuild. What once felt like the end of humanity might turn into a simple footnote in Earth's history. The result of a solar storm could be traumatic and life-changing, but humans would live to see another day. So, how likely is something like this? Well, it's tough to predict. We can look at the solar cycles and see how many solar flares occur, but there's no telling if they'll hit Earth or not. And although a solar storm could happen, well, keep in mind that even though we're more reliant on technology than ever before, our technology is also more resistant. Communication technology and power grids are built to withstand various types of interference. NASA is also working on technology to help predict and warn us about solar flares. If one is headed our way, well, here's what you can do to prepare. Keep a well-stocked emergency and first aid kit nearby. Like with any natural disaster, it's important to be equipped with first aid equipment, non-perishable food, and water. You might want to invest in surge protectors and remember to unplug any electronics if a solar storm occurs. Lastly, look into off-grid power supplies, backup energy sources like generators or solar panels. Then just wait it out. The world should return to normal.
1.3 billion years ago, two orbiting massive black holes, circling each other at 250 times a second, collided in a violent, universe-rippling explosion that sent waves of energy throughout the cosmos. In its wake, a new supermassive black hole formed over 60 times bigger than our Sun. Fast forward to September 2015, gravitational waves from this ancient cosmic event finally struck Earth. Luckily, the gravitational waves weakened over such a great distance. But what if we weren't so lucky? If a couple of black holes in our solar system collided, could we survive? What would happen to Earth if we got hit by massive gravitational waves? What causes these waves? And how can we detect them? In 1916, Albert Einstein made waves himself with his groundbreaking theory of general relativity, known famously by the formula E equals mc squared, or energy equals mass times the speed of light squared. He proved energy and mass are interchangeable, and that space, or space-time, curves in relation to the energy and momentum of whatever matter and radiation are present. With great foresight, Einstein inferred the collision of black holes, or massive stellar objects, create distortions in gravity, which are pushed out in all directions. Thanks to incredible developments in atomic measurement, scientists in Washington and Louisiana in the US at the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, were able to detect and measure the first ever gravitational waves here on Earth in 2015. This was a historic moment in science, as it was the first definitive proof of Einstein's theory of relativity. Using laser interferometry, observatories can detect a change less than 10,000th the diameter of a proton. That's 1 million times smaller than the width of a human hair. Since then, LIGO has measured 50 detections of gravitational waves. So, what exactly is causing these waves? And could they be catastrophic? There are many sources of gravitational waves, including the collision of black holes, the rotation of asymmetrical neutron stars, supernovae, or even remnants of gravitational radiation caused by the Big Bang. These waves travel at the speed of gravity, equal to the speed of light, and emanate outward in all directions. Like a rock being thrown in a pond, the ripples it creates dissipate over great distances and become smaller and smaller. Luckily, in our pocket of the universe, we are over 400 million light years away from any orbiting black holes. We're generally safe, but if these black holes happen to be in our solar system, the implications are much more dire. When gravitational waves pass through a planet, one side is compressed as the other expands, kinda like squeezing a stress ball. I could use one of those right now. As a result, time and space itself are stretched, causing a slight wobble. But if we were closer to this violent event and the waves were much bigger, this impact could potentially tear our planet apart, triggering powerful continent-splitting earthquakes, volcanic eruptions, and epic storms. Earth wouldn't really be a habitable place anymore, except maybe for extremophiles like bacteria that thrive in hydrothermal vents. Let's imagine our sun was a neutron star of an imperfect, non-spherical shape, sending gravitational ripples outward as it spins. Earth would likely look more like Io, one of Jupiter's moons, which is put under great gravitational pressure by Jupiter, and as a result is one of the most volcanically active moons in the solar system. Our landscape would be covered in lava and volcanic fallout, with an atmosphere made up of toxic gases like hydrogen sulfide. This would cause massive global warming and intense storms, constant tsunamis, tornadoes, and, well, you get the idea, climate chaos. We can count our blessings. We are nowhere near any massive objects shooting out gravitational waves. But thankfully, we can still measure them and learn more about the complexities of our universe. Even though we get hit by gravitational waves, they are generally so small, we can't even feel any impact.
Just 3,000 light years from Earth is a black hole visible to the naked eye. Thankfully, we're a safe distance from this stellar black hole and many others like it. There are approximately 100 million of them out there in our galaxy that we know of. They are remnants of supernovae, which occur when stars 10 to 20 times larger than our Sun collapse in on themselves. Stellar black holes are fairly common and are about 16 kilometers in diameter. And then there's the much larger competition: supermassive black holes. These have a diameter roughly the size of our solar system and a mass greater than 1 million suns combined. One of them, known as Sagittarius A, is right smack dab in the middle of our galaxy. So, how close would a black hole need to be a danger to us? Well, technically, a black hole the size of a 1 millimeter pin could destroy us if it was close enough to Earth due to its incredibly dense mass and extreme gravitational pull. Our survival all depends on whether we've surpassed the event horizon or not. You can think of this as the black hole's point of no return. Anything beyond this point would have to travel faster than light to escape. Yeah, good luck with that. If Earth got close enough, the side nearest to the black hole would begin stretching toward it. Our atmosphere would start to be vacuumed up, and then huge chunks of the Earth would rip apart and follow suit. If Earth managed to fall into the orbit of the black hole, we'd experience tidal heating. The strong, uneven gravitational pull on Earth would continuously deform the planet. This would generate a tremendous amount of internal friction, heating the Earth's core to disastrous levels. It would likely give rise to earthquakes, volcanoes, and deadly tsunamis. The trifecta of doom. Eventually, Earth would begin to stretch in a process known as spaghettification. And not in the tasty, cheesy, tomatoey way.
Mamma mia!
Let's say you were a superhero and decided to fight the black hole head first. Well, your arms would be closer than your feet, causing your body to stretch out vertically and become more and more compressed. Let's hope your superpower is elasticity. For an average-sized stellar black hole, spaghettification can occur several hundred kilometers away from the event horizon. But for a supermassive black hole, physicists believe that this would happen inside the event horizon due to its size. Eventually, no matter what size it is, anything entering a black hole would be ripped into a string of individual atoms. This would happen to anything that crosses it: people, planets, stars, you name it. Unfortunately, our whole solar system would be doomed. The careful balance of the sun and our many planets would collapse, which could send them crashing into one another. And to add insult to injury, our asteroid belt would get sucked toward us. About 200 of the 552,894 asteroids we know of are more than 100 kilometers across. So, if one hits us, we'd be dead before we would turn into spaghetti. Frankly, I'm not sure which fate would be worse. All of the matter in our solar system would join the accretion disk around the black hole. As matter gets sucked into the black hole, it generates massive amounts of radiation, so even if we somehow survived all the asteroids, we'd likely die from the radiation. Believe it or not, astronomers have discovered rare circumbinary planets that orbit two stars. While this may be a possibility with a black hole and our sun, the extreme tidal forces would likely make our planet uninhabitable. And worse yet, we might get kicked out of orbit or swallowed by the sun or the black hole eventually. Sorry, but there's not an outcome where we win here. But, and this is a big but, maybe we could find a way to protect ourselves in some hyper-reinforced space shuttle. If we somehow made it past the event horizon, we might be in for an even stranger time. Physics as we know it would change. Things like gravity, the speed of light, and even how atoms bind and react may be completely different. The truth is, we don't know what would happen. We can't get any information out of a black hole. Would we get pulled into another dimension? End up in a parallel universe? Or maybe we're already inside a black hole.
Oh my God! Oh Jesus! Oh my God!
Twinkle, twinkle, little star, how I wonder what you... What? Wait a minute. Why are you twinkling so much? Whoa, guys, that's no diamond in the sky. That looks like a supernova. As much as we love to blow stuff up here on Earth, no bombs or pyrotechnics could compare to the incredible force of nature's biggest explosion, the supernova. As a star reaches its grand finale and explodes, what would happen to life on Earth if we were close by? How far away from a supernova are we considered safe? Could anything survive its deadly radiation? And what makes supernovae valuable to us? Before you freak out, Earth is in a relatively safe patch of space called the local bubble. This peanut-shaped region of expanding gas in our Milky Way galaxy results from nearby supernovae explosions that occurred 20 million years ago. These explosions helped shape our solar system, spreading gas, dust, and heavier elements like uranium and gold to Earth. Without these supernovae, we wouldn't have any shiny gold bling or powerful nuclear reactors, so you can literally count your lucky stars. Okay, but are we in danger of any nearby supernovae? On average, a supernova will occur about once every 50 years in the Milky Way. Thankfully, there are no stars massive enough to become a supernova within 50 light years of the Earth. There is, however, one binary star system within 159 light years of Earth that could potentially put us at risk. Binary star systems are Type 1 supernovae. This happens in a tumultuous dance between two stars where matter is sucked from one star into another, typically a white dwarf. Eventually, the white dwarf explodes, resulting in an epic supernova. On the other hand, Type 2 supernovae occur when a star runs out of fuel and some of its mass flows into its core. Over time, the core will start to grow and get so heavy that it can't withstand its gravitational force, and then kablooey! the core collapses, and a supernova is born. When these explosions occur, a powerful blast of radiation is spread throughout space that will kill anything within 50 light years. To put this in perspective, our solar system is only about 2 light years wide, so the supernova's blast would be the distance of 25 of our solar systems in a row. If a supernova occurred as close as 30 light years away, we'd have bigger problems than a pandemic on our hands. The intense blast of radiation would carry a massive influx of high-energy neutrinos that would boil any living creature from the inside out. Hope you like your meals poached. The entire Earth could be vaporized in just a fraction of a second if the supernova was close enough. The shockwave would arrive with enough force to wipe out our entire atmosphere and even our oceans. The exploded star would grow brighter for about 3 weeks after the explosion, casting shadows even during the day. Even if life survived, the superheated gas from the supernova would emit deadly amounts of UV and gamma radiation. These rays would destroy the ozone layer, leading to the formation of nitrous oxide smog. We would all have to go deep underground and embrace our new lives as mole people to escape the lethal radiation and poisonous atmosphere. Unfortunately, there would be an increase in mutations and deadly cancers. And to top it all off, our phytoplankton, which account for almost 50% of all photosynthetic activity on Earth, would die off. Phytoplankton is vital to us and can absorb carbon dioxide from our atmosphere. Without it, we'd have a tougher time breathing. Global warming would accelerate even further beyond our control. And as an essential food source at the bottom of the marine food chain, a lack of phytoplankton would result in sea creatures becoming extinct. And eventually, humankind would too. So, like many what-ifs, almost everything dies.
No! No!
But there might still be a few lucky species of extremophiles that could survive the intense radiation. After a few hundred or thousands of years, the supernova would leave an impressive nebula in its wake. At the very least, we'd have a fantastic view in our night sky. Well, for those of us that can see.
Oh my god.
Is it a meteor shower? Space debris? No, it's something much, much worse. Our nearest neighbor is a full moon no more. The moon exploded and splintered into millions of fragments. Enormous lunar rocks are hurtling toward Earth. Could this wipe us off the face of the planet? How could the moon explode in the first place? And if we do survive, how would losing the moon change life as we know it? Okay, so how on Earth did the moon blow up? A blast mining operation gone wrong? A nuclear blast? A collision with a rogue planet? Whatever caused this catastrophe, you'd have to be packing some serious firepower to blow up the moon.
Guns. Lots of guns.
The largest nuclear bomb ever built, the Tsar Bomba, had the energy of over 57 million tons of TNT. Think that's strong enough? It's just a drop in the ocean compared to the amount of force you'd need to blow up the moon. You'd need the power of over 600 billion Tsar Bombas to destroy the moon. With anything less than that, the moon would just crack into pieces, and its gravity would pull it back together again. But if someone, or something, managed to explode the moon, it would spell bad news for us. The moon debris would scatter across the solar system, some into the abyss of outer space, and some headed straight for Earth. Earth's gravitational pull would immediately start to attract the moon rocks. As the moon's remains start to pick up speed, they would come crashing down into the atmosphere. Luckily, most of the smaller debris would burn up before it reaches us. Any larger pieces that got through would be traveling much slower than a similar-sized asteroid. The damage they'd cause wouldn't amount to much. But is it just me, or is it getting a little hot in here? The moon chunks aren't causing much damage, but the endless barrage of debris on our atmosphere would start to heat up the Earth. The whole world would start to get hotter and hotter, eventually getting to the point of incinerating all life. Talk about a bad way to go. Oh, and if you're thinking about trying to evacuate Earth, you better do it as soon as possible. The moon debris, combined with all the satellites it would destroy in space, would make any trip out nearly impossible. But what if you did manage to get out of Dodge or hunker down in the deepest parts of the Earth? What would life be like in the aftermath? Well, for some of us, it wouldn't get any cooler. The moon helps stabilize the Earth's axial tilt. It's what gives us seasons. With a new tilt, some parts of the Earth could be constantly exposed to the sun. In the worst case, the polar regions could start rapidly melting, raising sea levels and drowning out parts of the world. As the debris settles, the skies could look a little different. The remaining moon rock might cluster around the Earth, forming a giant ring like Saturn. But don't stop and stare too long. Every once in a while, some of the debris could rain down onto the Earth. Over billions of years, the moon's gravitational pull slowed down the Earth's rotation, giving us our 24-hour days. Without the moon, the Earth would start to rotate faster and faster. We'd have shorter days and stronger winds. Birds and insects would have a tough time surviving the harsh winds. Not only that, ocean tides would start to die down into tiny little waves. The moon's gravity helps create tides on Earth. Bummed out that you can't rip some gnarly waves anymore? Well, dude, there'll be a much bigger problem. It would wipe out all of the sea creatures that rely on the tides and ocean currents for survival. Our whole world would be literally flipped upside down. The Earth would burn up. Our days would be shorter, and the moon wouldn't be there to light up the night sky. You start your day hearing wild news. Jupiter has just swallowed Saturn. And it doesn't stop there. Jupiter is on its way to swallow every planet in the solar system. How big would Jupiter get? What would you see from Earth? And would Jupiter get rings like Saturn? This is What If, and here's what would happen if Jupiter swallowed every planet in the solar system. Jupiter has swallowed a planet before. Around 4.5 billion years ago, a protoplanet slammed into the young Jupiter. The protoplanet was 10 times Earth's mass, made of rocky and icy material. Jupiter's core broke apart and denser material mixed with hydrogen and helium. A few billion years later, the heavy material settled back into the dense core that we see today. Now, swallowing a single planet is one thing, but could Jupiter eat up all 7? In this scenario, you're going to see the planets get swallowed from largest to smallest, although we're saving Earth for last. Jupiter's first victim would be Saturn. From Earth, you could see these gas giants as 2 bright stars. And if you were to look up at the night sky as Jupiter swallows Saturn, well, all you'd see is Jupiter getting super bright. But if you were closer to the action, you'd see complete complete chaos. Jupiter is only 3 times heavier than Saturn, so it would be swallowing a planet that's almost its size. First, their moons would collide, creating massive amounts of debris. Some moon remnants would rain down on Jupiter, and some of the debris would float in space. As Jupiter was crashing into Saturn, Jupiter's surface temperature would become hotter than the Sun's outer layer. Whatever remained of Saturn would mix in with Jupiter's atmosphere. They would become one. Now, swallowing Saturn would increase Jupiter's mass and gravity by 30%. Jupiter would also sport prominent new rings from the shattered moons. Next, it would envelop the 2 ice giants, Uranus and Neptune. The 27 moons of Uranus would collide with the rings of Jupiter, adding to the floating debris. Uranus has an icy core made of water, methane, and ammonia, but Neptune's inner core is rocky. Regardless, both cores would melt as the planets crashed into Jupiter. Now, Jupiter would be almost 40% heavier, and it would head towards its first rocky planetary snacks. The rocky planets, Venus and Mars, wouldn't even make it to Jupiter's core. They'd burn up in Jupiter's atmosphere as if they were mere asteroids. Then we'd see our last planetary neighbor disappear inside this bulked-up Jupiter. Mercury is even smaller than Jupiter's largest moon, Ganymede, so it would get ripped apart by Jupiter's rings, adding to the speedy debris. Now, only Earth and Jupiter would be left, and Earth would be in big trouble. But how would Jupiter go about swallowing our planet? Even in its normal state, without swallowing 6 planets, Jupiter's gravitational force affects Earth. Yeah, every 405,000 years, the pull of Jupiter and Venus makes Earth's orbit wobble. It causes hotter summers, colder winters, and more rainfall in the tropics. And now, Jupiter's gravitational pull would be over 40% stronger. But Jupiter's pull would still be no match for the Sun's gravitational force, so Jupiter would have to come for Earth just like it swallowed all the other planets in our solar system. Jupiter doesn't have a hard surface like the rocky planets. You could say Jupiter is a big, dense ball of gas. Its surface is defined as the point where its atmospheric pressure is equal to Earth's. Well, so could Earth simply pass through? No. Just like the rest of the planets, Earth and all life on it would be toast. First, we'd be bombarded by asteroids while passing through Jupiter's rings. I doubt anyone would survive this, but if they did, they would see the Earth igniting as it enters Jupiter's atmosphere. Jupiter is so massive that even if it were to swallow its 7 planetary neighbors, it wouldn't even double in size. Now, what would happen if Jupiter continued to grow? Well, even if Jupiter increased its mass by 400%, it would stay about the same size. But the extra mass would make Jupiter so dense that it would start pulling in on itself. Yeah, it would get smaller instead of larger. And if Jupiter were to increase its mass by 70,000%, well, it could trigger a fusion reaction and light up like a star. About 50 billion rogue planets are roaming the Milky Way with no host star to hold on to. They don't give off any light of their own, and that makes them difficult to spot. Last time a stray planetoid the size of Mars smashed into Earth, it scattered our planet's young crust into space, where gravity glued those particles into what we now call the Moon. This time, it would be all hellfire and brimstone with no survivors left. And here's a timeline of how things break down. A few weeks before the collision, an unknown object would appear in the sky. It wouldn't happen overnight, no. We'd know something was coming. we'd see the planet slowly growing bigger, until one day it was as big as the moon. It would seem as if everything was unfolding at a relatively slow pace, but that's only because of the huge distances involved. Out there in space, the rogue planet would rush towards us at a speed of 11 kilometers a second. When the uninvited space intruder came into the moon's orbit, bad things would start to happen. The gravitational pull of the alien planet would make the tides on Earth 8 times larger than they are now. Floods would begin to rampage through the coastline cities. And still, the mega tsunamis are yet to come. 28 hours before the collision, the gravity of both planets pulling themselves towards each other would speed up the process. The incoming planet would hit a speed of 60 kilometers a second. Mega tsunamis would plot their way across the oceans. With this would come lightning storms, plus hurricanes and tornadoes so large they wouldn't have a number on the category scale. If you didn't book yourself a vacation or a spaceship that would take you to outer space, your time on this planet would be running out. 3 minutes before the collision, the rogue planet enters the Earth's atmosphere. Provided you hadn't already been killed by the lightning, hurricanes, flooding, earthquakes, or volcanoes, you'd see the rocky invader completely filling the sky above you. Nanoseconds before the collision, the atmospheres of both planets would be compressed together and glow brightly. It would get so hot that everything on the side of the Earth about to get hit would instantly vaporize. For the rest of the Earth, the ground would become scorching magma. Upon impact, the collision would cause friction between the two planets. Millions of tons of superheated rock would be sending a wall of fire in all directions. While the hellfire would rush across Earth's surface, the planet's inner core would be melting it from the inside out. This would have one big outcome. The Earth would collapse in on itself. The end of the era. If you did manage to get away in a spaceship, you'd see the massive remnants of both planets catapulted into different orbits. Some of them would hit other planets. Others would be fired out of the solar system entirely. Whatever was left would form a new asteroid belt encircling the sun. None of this would give any hint that there was once intelligent life on planet Earth. But hey, you can sleep well knowing that this won't ever happen. Well, most likely not. A mysterious interstellar object is on a collision course with Earth, and scientists don't know what it is. What could this new astrophysical object be? Where did it come from? Wait, why is it coming closer? Do you see this? What would this do to Earth? And you? This is What If. And here's what would happen if a hydrogen iceberg fell to Earth. In 2017, scientists discovered the first known interstellar object in our solar system. Meet Oumuamua, which means scout in Hawaiian. According to NASA, this cigar-shaped object is around 400 meters long. It was discovered as it was slingshotting around the sun at over 87 kilometers per second. The verdict is still out on what Oumuamua is. It could be a comet, asteroid, or maybe something else. One leading theory is that it's a hydrogen iceberg. That's because scientists observed Oumuamua accelerating away from the sun instead of floating toward it. It's as if this interstellar object had a little jetpack blasting it further into space. But if it blasted its way into Earth's atmosphere, would it trigger a deadly chemical reaction? If Oumuamua was solid hydrogen ice, it would have been formed in extremely cold conditions. Hydrogen sublimates or turns from solid to gas at a frigid minus 267 degrees. And because empty regions of space average out at a temperature of minus 270 degrees, It makes sense that this object could maintain its solid hydrogen structure. As it rounded our sun, that ice on the surface of Oumuamua would vaporize, and that would create the vaporous jets propelling the object straight at you, just like a rocket. This would also explain why Oumuamua has such a strange shape. It was heated by the sun, and it became smaller and thinner, like a used bar of soap. But while empty space may be frigid, the temperature around the sunny side of the Earth could get as hot as 121 degrees. This means our interstellar guest would continue to diminish in size as it traveled closer and closer to Earth. And that wouldn't be the hottest temperature Oumuamua would experience. Like other meteors that enter our atmosphere, it would heat up to a scorching 1,648 degrees. It would just melt before it could ever reach the surface. For this space iceberg to make a devastating impact on the ground, it would need to be massive. But that doesn't mean you'd be entirely safe from catastrophe. The real danger of this scenario is something much, much smaller: molecular hydrogen. Hydrogen is known as an indirect greenhouse gas. This makes it different than gases like carbon dioxide or methane. Greenhouse gases trap heat directly. Our atmosphere currently contains about 0.00005% molecular hydrogen. And if a hydrogen iceberg vaporized inside of it, this could accelerate the effects of global warming. As soon as hydrogen filled the atmosphere, it would react with hydroxyl radicals. These molecules are produced by water vapor, ozone, and sunlight. And they typically react with gases like methane, helping to reduce its concentration in the atmosphere. If Oumuamua released a lot more hydrogen into our atmosphere, the methane concentration would increase as well. And methane is 25 times more potent as a heat-trapping gas than carbon dioxide. Who knew that this interstellar visitor could come with a risk of growing global temperatures and sea levels, as well as more severe storms? But before you start picturing Earth-destroying scenarios in your head, don't worry, Oumuamua is long gone. And even if this stellar iceberg came back and set its course on Earth, it would need to be truly massive to cause that kind of damage. An asteroid is headed straight toward Earth. Initially, scientists thought it would miss us, but they've made some serious miscalculations. And now it's headed right toward our giant blue marble. What happens next? Does this mean the end of humanity? Can we change the trajectory of the asteroid? And why might this actually happen by the year 2029? Now, this sounds like a fun hypothetical, but an asteroid coming for Earth? It's no laughing matter. It could happen. Scientists had thought that asteroid 99942, also known as Apophis, might hit Earth by the year 2029. Apophis was discovered in 2004, and scientists have been closely monitoring it ever since. At one point, research suggested that the asteroid had a 2.7% chance of hitting Earth. Yeah, scary, I know, but since then, new calculations predict that the asteroid will whiz by Earth at a distance of 30,000 kilometers. Now, considering that the moon is 380,000 kilometers away, this asteroid will be incredibly close. But at least it won't be hitting us. And of course, calculations can be wrong. Let's say that in this case, they are, and Apophis is coming right toward Earth. Way ahead of schedule. The asteroid is going to hit us this year. Okay, let's see what we're dealing with. Apophis is 340 meters in diameter. For reference, that's taller than the Eiffel Tower. But is it the worst asteroid Earth has ever seen? Nah, lucky for us, it's not even close. The Chicxulub asteroid that wiped out the dinosaurs was estimated to be 10 to 15 kilometers wide. So now we're dealing with Chicxulub's little brother. So what does that mean for us? Will humans go extinct from this impact? Well, more on that in a bit, but first, let's look at whether we have any chance of stopping this asteroid. Okay, the first step would be identifying the asteroid, which we've already done. We know how big Apophis is and that it's moving at about 30 kilometers per second. Now it's about the defense measures we could use. There's a couple being looked into right now. One of them being the kinetic impactor. This involves sending a spacecraft to collide with the asteroid, all in hopes of changing its velocity and trajectory. NASA has run some successful tests using this method, so that's an option. Next would be what's known as a gravity tractor. A large spacecraft would fly next to the asteroid, and over time, its gravitational pull would eventually change the asteroid's path. Laser ablation is next on the list of options. Yeah, special lasers could be used to vaporize parts of the asteroid's surface. This wouldn't destroy the asteroid, but it could alter its direction as well as the size and impact of it. And last but definitely not least is the final nuclear option. Yeah, that's right. As a final resort, we could nuke Apophis. And with the asteroid's massive size, as well as the lack of time we have before it hits us, this might be the only option. But don't be too quick to hit that red button. Nuking an asteroid can have some serious downsides. It could split the asteroid up, causing it to fragment. Then you'd have dozens more minor asteroids and meteors coming toward Earth, making the impact even more devastating. Yeah, and these wouldn't just be regular asteroids either. Because of the nuke, they'd be radioactive. This would mean that significant parts of the world would not only be impacted with asteroids and meteors, but they'd also experience radiation levels only seen during nuclear warfare. So, what's the best option here? Well, it's tough to decide. Let me think about this for a second. Oh, well, it's too late now. We took too long deciding what to do, and now the Apophis will be here any second. Brace yourselves. You wouldn't get a good look at the asteroid impact, and that's because it landed somewhere in the middle of the Pacific Ocean. This is the most probable spot an asteroid would land, considering the Earth's surface is mostly water. So you might not see the impact, but you definitely notice it. Once the asteroid hit our planet, it would be as devastating as several thousand nuclear bombs going off, just with a lot less radiation. It would make a crater at the bottom of the ocean as big as a kilometer wide. And what would happen next would be even more devastating. The massive impact would create giant tsunamis that would rage worldwide. Several hours after the asteroid touches down, cities along the Pacific coast would feel Apophis's impact. The tsunamis would travel across the Pacific Ocean at jetliner speeds. Places in North and South America like California, Peru, and Chile would face towering waves. Due to the energy from the asteroid, it would likely cause waves taller than 30 meters. Waves as big as this are responsible for one of the most devastating tsunamis ever. In 2004, Southeast Asia experienced a tsunami that generated waves over 30 meters tall, killing over 230,000 people. But instead of waves like these reaching just a few countries, this would be a complete global catastrophe. Not only would the Americas experience these tsunamis, but so would Japan, Australia, and the Philippines. These places would all be devastated by the impact. Tsunamis like these would likely destroy millions of lives. So that's what would happen if an asteroid hit the ocean, but what if it made impact on land? Well, to start, the impact crater would be much more significant. We know that an asteroid's impact crater can be anywhere from 10 to 20 times the size of the asteroid itself. And now there isn't any water to soften the blow, so the diameter of the crater could be as large as 7 kilometers, with a depth of over 1 kilometer. Depending on where it lands, this asteroid could be big enough to devastate entire cities. The initial impact would send a massive shockwave that spreads for hundreds of kilometers. This could destroy entire buildings and seriously damage infrastructure. It would throw tons of dust and debris into the atmosphere. It could get so bad that it could cause an impact winter. This would be caused by a dust cloud temporarily blocking the sun, causing crops and vegetation to die out, which creates even more casualties. Something like this could last weeks or months and be an overall environmental catastrophe. This entire event, during and after, could cause millions of people to be killed, depending on where the asteroid lands. We can only hope that an asteroid collision like this would land as far away from people as possible. But now for the good news. If Apophis did somehow make an impact, it wouldn't cause a mass extinction like the Chicxulub asteroid did for the dinosaurs. The event would be incredibly traumatic and have lots of casualties, but humanity as a whole would live to see another day.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen if a magnetar entered our solar system.
If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood, but if it decided to stop minding its own business, there are 2 ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy. In just 1/5 of a second, it released more energy than our sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar. So, we all know about the Big Bang, right? The cosmic explosion that created our universe? Well, as with everything, there is a beginning and an end. This is the Big Rip, the ultimate fate of our universe. It will be a cosmic event that will tear apart galaxies one by one. Stars, planets, you, everything will be eviscerated. Luckily, it's not going to happen for another 20 to 30 billion years. But what if we weren't so lucky? What if the Big Rip happened tomorrow? What would happen to our planet? And would this really be the end of everything we know? This is What If. And here's what would happen if the Big Rip happened tomorrow. In the future, the Big Rip will literally tear apart the universe. A process that will take about 1 billion years from start to finish. But the mad scientists here at What If have sped up the clock.
So that's, coming along.
The Big Rip is now scheduled for tomorrow. Try to get some sleep now, you've got a big day ahead of you. So, how will this go down exactly? Well, something called dark energy is driving the expansion of the universe. So, as the universe expands, so does the dark energy. During this expansion, dark energy transforms into something called phantom energy. And no, it's not just going through a goth phase. If this transformation happens and the phantom energy increases faster than the expansion of the universe, the Big Rip is set to make its debut. Think of it like a water balloon, and the water is filling the balloon up too fast. Eventually, the balloon will pop. But in this case, it's not a balloon, it's the entire universe. Meanwhile, back on Earth, you're going to have a very, very interesting day. Imagine that you're looking up at the beautiful night sky and you see a shooting star. Wait, that's not a shooting star, that's the Andromeda Galaxy. And it's moving away from us. That's weird. So, since you're confused about what's happening, you whip out your telescope and try to get a closer look. You try to look for other galaxies in the local group of galaxies, but they're gone. Suddenly, all the stars start moving away from you. It looks like you're traveling at light speed. That's the Milky Way breaking apart. You see Saturn shooting through the night sky, and oh my, there goes Jupiter, and oh gosh, you got Mars too. Then, all you see is blackness. The sky is empty of any stars. There's just complete darkness. Okay, it can't get any worse, can it? Well, now the ground is shaking and you see massive tidal waves, earthquakes, and volcanic eruptions. This is because the moon is breaking away from Earth's gravitational pull. But before you even have a chance to react, the Earth will be snatched away from the sun and it's going to get really, really cold. And for the grand finale, our planet will be torn apart and explode. Luckily, you'll be dead by the time this happens. Yeah, you heard me. I said luckily. If you manage to survive long enough during the explosion, you'd be able to witness your own disintegration. All of your molecules would be getting pulled apart. As you unraveled, all the atoms that make up your body would be swirling around, disintegrating into electrons and protons and neutrons. And then, poof, they'd rip apart as well, leaving nothing behind. Nothing is sacred to the Big Rip. And as the universe keeps expanding, it'll get ripped apart too. The universe is gone. Just gone. Or at least, it's gone as we know it. We have no idea what would occur after the Big Rip. That's totally unknown. So, sorry for the spoilers, but that's how we close the book on our universe. Thankfully, we'll all be long dead before the Big Rip happens. And that's because another cosmic event is going to kill us first. What if our sun decided to call it quits and explode tomorrow? Well, that's a story for another What If.